Hey guys, today I'm going to be discussing data representation, specifically ones and twos complement. Everything you need to know from the range of it, the pros and cons of both, and why two's complement is used over one's complement. This will help you guys in any computer architecture class you take, or in general, just like if you want some information about how to represent signed numbers in binary. So say we have the number for example, 0, 1, 0 in binary, which is what we all know to be 5. Say you want to represent this as a negative binary number. So all ones complement this method is telling you to do is negate all the bits. So we have 1, 0, 1, 0. Negation just means you make the number that you had before, just make it the opposite, which is really easy to do in binary because there's only two numbers used in binary, it's just 1 or 0. So this is our representation of -5 in ones complement. Now, it's very easy to have a binary number of any amount of bits. For the sake of this video, I'm going to do everything in 4 bits because it's simpler. But say we have 4 bits and it's just easy to find them. But as you'll see, one's complement isn't as good as two's complement for these reasons. First of all, it's inconvenient for arithmetic. So when you add, subtract, divide, do anything with one's complement numbers, you'll find out that it's very difficult it's very difficult because you'll have a lot of carryouts and you'll have a lot of overflow that you have to deal with extra steps that are just unnecessary when you have a representation as two's complement, as we'll discuss in a bit. Also, and a very important reason is there's 2 representations of 0, which is just unnecessary. So you have 0, 0, 0, 0, and you'll have 1, 1, 1, 1. So these individually represent +0 and -0. This is what hurts the arithmetic and just hurts the reason behind using one's complement. Computers don't want to use 2 representations of 0, and it's very hard for programmers and computer architects to in general use this method because there's two's complement, which is so much better. Say you have the same number, as we used before, which was I think 5. So you have 0, 1, 0, 1, right? So you follow these steps now for two's complement. This is a completely different method than one's complement. So you negate all the bits. 1, 0, 1, 0. Let me just divide these so you don't think I'm using that. And then after you negate, you simply add 1. And somehow, I'm not going to go behind the theory behind all this, but somehow that eradicates like 90% of the problems that one's complement has. So you end up at 1, 1, 0, 1. And this is our representation of -5 in two's complement, which is just another way to represent assigned numbers. So the pros of this, there's only one representation of 0, and that's 0, 0, 0, 0. And this is a good time to discuss the most important part of two's complement, which is this first significant bit, or what we call is a sign bit. What this is going to do is going to tell you straight off the bat, all right, my number is negative or my number is positive. If your number starts, given however many k bits you need, like say you have 8 bits or 9 bits, the first bit is going to tell you whether or not your number is positive or negative. So right off the bat, we can see -5. So we know now that 1, if your most significant bit is 1, it's going to be a negative number. And let me just scroll down real quick. And then if it's 0, it's going to be a positive number. And you'll see this as a trend when you do one's complement anytime. That's why there's only one representation of 0, because you can only have one positive number. You can't have the array of ones as one's complement had before. Another reason that two's complement is just better is because arithmetic works fine, although there is some overflow, as we'll discuss in a bit. And in general, two's complement is widely used in computers. And just try to remember the difference between ones and two's complement. and just because this will show up on an exam if you've learned it in class, because professors just want to get out the knowledge that you understand the difference between the two. It's very easy to find ones and twos complement. I mean, you're just negating all bits, or negating all bits and adding one, so it's not that difficult. The more important part is the theory or the idea behind both. So let's discuss the overflow, which is an important part. So there's two types of overflow. It's when you add two positive numbers and you get a negative, which is not supposed to happen, or vice versa if you add two negative and you get a positive. So let's do some examples of each. First, we'll do adding two positive numbers. So say we want to add 7 plus 1. That should give us 8, right? So let's do this all in 2's complement. I'm going to give you 7 in 2's complement. I'm going to do it all in my head because at some point after you like practice a little bit, you'll see that it's very easy to convert the 2's complement in your head. Just work with it a little bit and you'll see. And then 1's in 2's complement, it will be 0, 0, 0, 1. And now let's just simply add this up as we would any binary number. So at the end we get 0, 1, we have our carry, we get 0, 1, carry, and then 0, and then 1 carry up here, and that just turns into 1. So what is this number in 2's complement? Since our first bit right here is negative, and we just try to, once we understand the concept of 2's complement, this will be really easy, and we get -8. Obviously, these two numbers are not the same, thus we have an overflow. And this is the first example of adding two positive numbers and receiving a negative, which is obviously, if you get this is overflow error. Sometimes your professor will try to trick you and tell you to add two numbers, and this will happen. You'll be confused, and just remember that this is overflow and just write that down. Next example we'll quickly do is two negative numbers being added together, and that'll give you a positive number. So let's do simple numbers. We'll do -8 plus, remember you're just doing plus, -1. Now this should give us -9. Let's see what it gives us when we do 2's complement. So 1, 0, 0, 0 is -8 in 2's complement, and what's -1? It's just a bunch of 1's. When we add this up, we get 0, and then this is a useless bit. It's the carry bit. You just ignore that. You're just working with these numbers. So our first bit is positive. So right off the bat, you can see that it's already wrong. Let's just write it out. This is 7 in 2's complement. And obviously these two numbers are not the same, so we have another overflow. So far you should understand how to convert into 1's complement, why it's bad to do 1's complement, the pros and cons of 2's complement, how to detect the cons. The only con of 2's complement is the overflow, and how to detect that you should now know. And finally, we're going to go over the range of 2's complement, which is pretty important. So say you're given a k-bit binary number. Like I said in this video, I'll be using 4 as the bit range of my numbers. So let's just do the min and max of this. So min is simple. We have a certain not formula, but like we have a set range. So we know that our min of a 2's complement given k bits will be -2. My k is 4, so 4 minus 1. Now what is this equal to? This is equal to -8. And then we have our max possible number representation in 2's complement, which would be 2 to the 4 minus 1 minus 1, and that's simply 7. Now we can just take these two numbers and find out what they are in 2's complement. So -8 is simply 1, 0, 0, 0. And from what we learned before about our assigned bit, this bit represents whether or not it's positive. The first significant bit is whether or not the number is positive or negative. Obviously, we want our min value to be the smallest it can, so that's why the first bit is negative. And then for our max value, you want it to be positive. So our first bit's going to be that 0, and then the rest of the bits are going to be 1, and that's our range. And this can literally work for any k bit of numbers. So you can work with this with 18 bits, anything. Just use this range formula, and this is definitely the type of questions that can pop up are like find a range of 9 bits. It'll ask you to write down the exact number, and this is simple. You just plug in the amount of bits they give you and you can find your answer. And I hope you guys found this helpful, and see you guys next time.